Okay, TMAT108 students, this video is for the Unit 1 exam for the review problems, specifically numbers 9 through 15. So for question 9, it says perform the operation. And we're given 12x cubed plus 11x squared minus 3x plus 20 is all divided by 3x plus 5. So one of the things to notice that the operation that's going on here is division, but the thing that we're dividing by is not a monomial. Specifically, this is a binomial. So we can't break this up into a series of separate fractions and then simplify them piece by piece. Because that is not a monomial, in order to do this division, we're going to need to use long division. So I have this problem repeated over here to give myself a little bit extra room. For the long division, the numerator, which is referred to as the dividend, will go underneath your long division symbol. So I'll have the 12x cubed plus the 11x squared minus 3x plus 20. And I'm dividing it by the 3x plus 5, which is referred to as my divisor. Alright, so let's go ahead and start the long division process. To start, we look at the first term underneath and then the first term on the outside. And we would ask ourselves, 3x times what gives us 12x cubed? So to get from the 3 to the 12, I'm going to need to multiply it by 4. And then get from x to x cubed, I need to multiply it by an x squared. So that 4x squared goes above the line. I'm going to take the 4x squared, multiply it by everybody on the outside, and write it on the line underneath, putting my like terms together. So 4x squared times 3x is 12x cubed. And then 4x squared times positive 5 would be positive or plus 20x squared. So now what we need to do is we need to subtract this polynomial from the one above it. When we do the subtraction has to distribute through. And sometimes it can get a little confusing what signs we end up with, because when this subtraction distributes through, everybody will change its sign. So I like to have the sign right next to the term. So when I distribute the subtraction, I'm going to change this to a plus, and I'm going to circle it to remind myself I'm changing it because I'm distributing the subtraction through. And then I'm going to write a negative next to this first term, and then a negative next to this second term. I'm going to circle it to remind myself those are the new signs from distributing the subtraction. And now I can add going down, knowing that I have the right signs next to the terms. When I add going down, these first two terms are going to be opposites. They're going to cancel, and that's what should happen. That's why we picked this number up here. Over here, 11x squared plus negative 20x squared is negative 9x squared. Now we're going to bring down the next term, minus 3x. And we're going to start this process all over again. I'm going to look at first term right here and first term out here. And I'm going to ask myself, 3x times what gives me negative 9x squared? Well, from 3 to negative 9, that's going to be a negative 3, which I'll write up here as minus 3. And then from x to x squared, I need to introduce another x. I'm going to take the thing that I just found, which is the negative 3x. I'm going to write it or multiply it by everybody on the outside, and I'm going to write that new polynomial underneath here. So negative 3x times 3x is negative 9x squared. And then negative 3x times the positive 5 is going to be minus 15x. Now we're going to subtract going down. But so I can have the right signs next to the terms, I'm going to come through and I'm going to distribute the subtraction. So then out here technically is a plus. This negative 9x squared becomes positive, and then the minus 15x, that also becomes positive. And I'll circle those to show that those are the adjusted signs. So then when I add going down, because I have the right signs next to the right terms, these first two terms cancel. They're going to be opposites. And then right here, negative 3x plus 15x is going to be positive 12x. Now I'm going to bring down the next term, and I only have to do this one more time. So here we go. I'm going to look at the first term out here, and then the first term right here. And I'm going to ask myself, 3x times what gives me 12x? So I already have the x, I just need to build the number, so that's going to be a 4, or specifically a positive 4. So above the line, don't forget to write the plus to account for that sign. 4 times 3x is 12x. And then 4 times 5 is going to be positive 20. So we're going to subtract that polynomial from the line above it. To distribute the subtraction through, everybody's going to switch its signs on that second line. So then I'll have 12x plus negative 12x. Those guys will cancel. And then 20 plus negative 20, those guys also cancel. So I get 0 down here, which is called the remainder. So we have found then for this problem that the answer is 4x squared minus 3x plus 4. That's my quotient. And then my remainder, just to kind of keep track of it, is 0. Now, if you ever wonder, did I do this right, you should know how to check this using the multiplication. So to check it, what must be true is the dividend must equal the divisor times the quotient, and then plus any remainder. By the way, it's helpful to do a couple of long division problems with actual numbers before getting into the polynomial stuff, just to remind yourself of the process and the connections between the division and the related multiplication. So in this case, my divisor, what I was dividing by, was 3x plus 5. We're arguing that the quotient is 4x squared minus 3x plus 4. And for this particular problem, my remainder is 0, so I don't have to worry about that. So let's check if I do this multiplication, do I get back to my dividend? So let's go ahead and start distributing this out. So 3x times 4x squared is 12x cubed. 3x times negative 3x is negative 9x squared. 3x times the positive 4 is going to be plus 12x, and that's my first set of distributions. Second set of distributions is 5 times 4x squared is going to be 20x squared. I'm going to go ahead and record that underneath my other x squared term, kind of building a x squared column. Second distribution would be 5 times negative 3x, or minus 15x. Again, I'm going to record that underneath my x term that I already had. And then last distribution would be 5 times 4, or plus 20. So let's add going down. So I'll have 12x cubed plus 11x squared minus 3x plus 20. And if everything is done correctly, and then the remainder would be plus 0, so there's no adjustment for this for the remainder. And then if this is correct, this should be my dividend. And if we compare that to what we were originally given, it was. Okay, so the whole process checks out. Alright, so let's take a look at the next one. It says find the equation of the line with slope negative 1/3 and goes through the point negative 2, 4. Write the equation in slope-intercept form. In order to start this process, though, we're going to start using what's called point-slope form. So point-slope form, is used when you have a point on the line and the slope of a line. And it looks like y minus y1 is equal to m parentheses x minus x1. So let's substitute in what we know. So I'll have y minus, the y coordinate of the point I was given was 4. My slope is negative 1/3. And then I'll have x minus, the x coordinate of the point I was given was negative 2. So be careful with your signs right here. When we go to clean up this double negative that we have right here, we'll have y minus 4 is equal to negative 1/3, so then x plus 2. Alright, so let's go ahead and distribute that negative 1/3 through. So I'll have y minus 4 is equal to negative 1/3 x for the first distribution, and then negative times a positive is negative, and then 1/3 times 2 is 2/3. So we've broken those parentheses. Now the last thing we're going to do is we're going to write it in slope-intercept form. So in slope-intercept form, that means we want to solve for the variable y. So in order to move the, get the y by itself, we'll move the 4, or specifically the negative 4, to the other side by adding it. In order to put these pieces together, I'm going to need common denominators to add those fractions. You could use your calculator to do it, but it's always good to review skills, just to keep them fresh. So negative 2/3 plus 4 over 1. My common denominator is going to be 3. So then I'm going to have negative 2/3 plus, and if my second fraction scales up to a denominator of 3, that's a times 3 relationship. Old numerator times 3 gives me 12 for my new numerator. Now that I have common denominators, we can add our numerators together. So negative 2 plus 12 is 10, and then the common denominator drags through. So then this will end up giving me y is equal to negative 1/3 x plus 10/3. On the next problem, we are asked to solve the equation, and it's 1/2 minus x plus 3/2 is equal to x minus 4. Now it is possible to work with it in this form, but I would recommend, just to make our lives easier, because this is an equation, that we're going to clear the fractions. And in order to clear the fractions, what we're going to do is we're going to multiply through by the least common denominator of all the fractions in the problem. Now in this case, that common denominator is pretty easy to find because I actually already had a common denominator. We're going to multiply everybody by, in this case, 2. Now when you multiply, you have to multiply everybody. So everybody gets a 2 multiplier, even the stuff that wasn't a fraction. Okay, so we'll multiply every term by 2, and then let's see what we get. I'll write it over here. Here we go. Alright, so the 2 times the 1/2, those 2's are going to cancel, and I'll just be left with the 1. Minus 2x plus, here the 2's cancel, and I'll just be left with the 3, equals 2x minus 8. So now I have something that's structurally a little easier to work with and no more fractions. So let's go ahead and solve this equation. Over here on the left-hand side I have some like terms to put together, so I'm going to get 4 minus 2x is equal to 2x minus 8. We'll go ahead and add 2x to both sides to get our x terms together, and I'll go ahead and add 8 to both sides to get the constants together. So then we'll get 12 is equal to 4x, and dividing both sides by 4, we get 3 is equal to x. So there is the solution to the equation. If you weren't sure if this was the solution, you could take it back into the original equation and put it in for everywhere you see an x. And follow order of operations. The number you evaluate on the left-hand side should be the same thing as the number you would evaluate on the right-hand side, so you can verify that this is truly the solution. On the next problem, we're asked to solve the equation 5y minus 7 plus y is equal to negative parentheses y plus 3y. So I'm seeing that I have some like terms over here I can put together. So 5y plus y is 6y minus 7 is equal to, and then on the right hand side, inside the parentheses, those are also like terms. I can put those together. So y plus 3y is 4y. But don't forget about that negative sign that was floating out in front of that thing. So let's get our y terms together. So I'm going to subtract 6y from both sides. So I get negative 7 is equal to negative 10y. We'll divide both sides by negative 10. So let's come up here, negative 7 is equal to negative 10y, divide both sides by negative 10. And then over on the left-hand side, a negative divided by a negative is positive. 7 divided by 10 doesn't divide nicely, so I'm just going to leave it as 7/10 as a fraction. And there's the value for my variable. On the next problem, I'm asked to find the slope of a line through the points -2, 4, and -6, -5. The slope, which we use the variable m typically, is going to be found by looking at how much the y-coordinates change over how much the x-coordinates change. So it is a fraction structure where in the numerator we find the difference in the y values, in the denominator we find the difference in the x values. So we can use the formula that if I'm looking at the x-coordinate in the first ordered pair and the y-coordinate in my first ordered pair, which are written x sub 1 and y sub 1, and then I have the x-coordinate in my second ordered pair and the y-coordinate in my second ordered pair, which I can write as x sub 2, y sub 2, then I can find my slope m by doing y2 minus y1 over x2 minus x1. So let's go ahead and then figure that out. So my y2 is negative 5 minus my y1, which is 4. That builds my numerator. And then my x2, which is negative 6, minus my x1, which is negative 2. So be careful with your sign down there. Okay, the subtraction is part of the formula, and then you're also putting in a negative number. When I go to simplify that, upstairs I'll have negative 9. Downstairs I'll have negative 6 plus 2, or negative 4. And then a negative divided by a negative is a positive, and then 9 divided by 4 doesn't divide nicely. And nothing goes into 9 that also goes into 4, so I can't simplify that fraction anymore, and I would be done. The slope is the slope is 9/4. And don't convert that to a mixed form, and definitely don't convert that to a decimal. We leave it as a fraction like that. On the next problem, I'm asked to perform this operation. So it says 1/3 x to the 4th inside the first set of parentheses, and in the second set of parentheses it says 1/7 x to the 6th. Notice that these two sets of parentheses are touching, so that indicates the operation of multiplication. A couple cool things to know about multiplication is the properties are associative and commutative. The associative property says that the groupings or the parentheses don't really matter, so I can omit them. It's multiplication all the way through, so I don't really need those parentheses. And then the commutative property of multiplication says you can move things around in a multiplication problem, and that doesn't change the outcome that you get. So if I remove the parentheses and then can move pieces around, I could write this as 1/3 times 1/7 times x to the 4th times x to the 6th. And the reason why I would want to do that is I want to put these fraction things together and then the variable things together. 1/3 times 1/7 is 1/21. And then x to the 4th times x to the 6th, because you have the same base, you add the exponents, you would get x to the 10th. So you can leave it as 1/21 x to the 10th, writing x to the 10th off to the side. Or, if you want to be very specific, you could write it as x to the 10th divided by 21. Just to be super clear that that x to the 10th actually lives in the numerator of the structure and not the denominator. Either one would be okay. And then for the last one we're going to look at is a word problem. It says a 15-quart cooling system is checked and found to be filled with a solution that is 40% antifreeze. The desired strength of the solution is 60% antifreeze. How many quarts of solution need to be drained and replaced with some pure antifreeze to reach the desired strength? This type of problem can be called a mixture problem. So I have some stuff that I'm trying to mix together to reach a desired mixture. I like to set these ones up in a table to keep track of everything that I'm putting together. So the two things that I'm starting with, I'm just going to call mix 1 and then mix 2. And then what I'm hoping to achieve, I will just call my desired mix. So this is going to go on the leftmost column of a table. Alright, so from that then, I'm going to finish my table by building some other columns. The first column I'm going to keep track of is the concentration of the mixtures that I'm starting with. And the next thing I'll keep track of is the quantity, or how much of that particular concentration I have or I'm using. Now, if I take a value's concentration and I multiply it by the quantity, or how much of it I have, I will ultimately end up with what I'm going to call an overall value, or how much of whatever that concentration is that I'm tracking, how much of it I truly have in that particular mixture I'm looking at. So it helps to maybe put some numbers in here so we can see what we're going to be tracking and what we're talking about. So the first thing I start with is I start with a 40% mixture. So that's its concentration. I want a 60% antifreeze mixture. So that's my desired mixture concentration. And that's what I want in the tank. And the tank holds 15 quarts. So the overall quantity of my desired mixture is 15 quarts. Now, in order to get a 40% concentration up to a 60% concentration, we're going to be draining some of the antifreeze in this system, or some of the solution in the system, and we are going to be putting in pure antifreeze. So pure antifreeze, which will be mix 2, has a concentration of 100%. Now the question is, how much should be drained and then replaced with that pure antifreeze? So that's where I'm going to assign my variable, is the quantity of the pure antifreeze that I need. Now ultimately in this tank I have to have 15 quarts total. So my mixture number 1, the quantity of that I will have in the tank, will be, I don't necessarily need to assign another variable there. Now you could, that creates something called a system of equations that we're not going to talk about right now. But I don't necessarily need to assign another variable there. I can say that the quantity that I will have of the 40% concentration mixture is my total, 15. If I take away x, which is what it's going to be of this other mixture's quantity, that will tell me what I have left for my 40% concentration mixture. Maybe to think about it in terms of a concrete number, let's say that I tell you that the tank holds 15 quarts, and let's say we know mixture number 2 of the pure antifreeze, I want 2 quarts of it. Well, if I have 2 quarts of this, then that means I must have 13 quarts of this in order to have 15 quarts total in my system. So if I know what the total is, I will take away what I've already accounted for, and it will tell me what's left. Okay, so I can write an algebraic expression for that first mixture. Now, the overall value is found by multiplying the concentration times the quantity. So for this last cell right here, it's going to be the 40%, and 40%, by the way, as a decimal. If I move that decimal point left 2 spots, that would be 0.40. 100% as a decimal would be 1, and 60% as a decimal would be 0.60. So for this overall value cell, it's going to be its concentration, which is the 0.40, times its quantity, which is 15 minus x. Since the quantity has more than one term, we're going to need to keep it inside a set of parentheses so all that information stays together. For mixture number 2, its overall value is its concentration, which is 1 times its quantity. And in that case, I am actually going to write the 1 because I want to see kind of the symmetry and how we're building all these last cells. And then for the desired mixture, its overall value is its concentration, which is the 0.60, or the 60%, times its quantity, which is 15. And this last column is where I'm going to get my equation. Is if I take the value that's generated from mix 1 and I add it to the value that's generated from mix 2, that has to ultimately give me the value for my desired mixture. Or as an equation, it looks like this. 0.40 times 15 minus x plus 1x is equal to 0.60 times 15. And this is an equation just in one variable that I can solve for. If I look over here on the right hand side, the 0.60 times 15, if you multiply that, you get 9. All right, so just to kind of maybe write that up here, just to tie back to how the overall value is the concentration times the quantity. If I've got 15 quarts of something, and I know the concentration of it is 60% antifreeze, that means in those 15 quarts, 60% of 15, or 9 quarts, is the actual antifreeze, and then that means then the remaining quarts, or the remaining 6 quarts, have to be the something else, the other parts of the solution, whether or not it be water or you know, sometimes in medical situations it's like saline, but it's whatever the other part is that this material is being mixed with. So that's why we're tracking how much antifreeze is happening in each of the different parts to make sure I have enough antifreeze for my desired mixture. Alright, so let's go ahead and figure out what's happening on the left hand side. So 0.40, I'll distribute that through. So 0.40 times 15 is 6, and then minus 0.40x. Now I don't need those trailing zeros, but I like to keep them because I like to be able to look at my work later and very much see 40% and 60%. Plus 1x, you can just write that as x if you want, is equal to 9. I'm going to get my constants together by subtracting 6 from both sides, and then I also have some like terms here I can put together. So negative 0.40x plus 1x, combining the numbers in the front, is going to give me positive 0.60x is equal to, and then on the right hand side, 9 minus 6 is 3. Solving for the variable x, we'll divide both sides by 0.6 or 0.60. And so then you get that the value for x has to be 5. So what we have just found is that we needed to drain the system, and we need to replace it with 5 quarts of the pure antifreeze at 100% concentration.